Hi, Catherine. I'm going to go through your test with you. Just as a note, when you send me an email, can you just always let me know what class you're in? Usually, I have to then search through all my classes to figure out what file I have to go into. So, and with my luck, it's always the last one. So I went through all my classes, and the last one I found you. I figured out where you were, which class you're in. Okay. So you sent me a HEC file. HEC files don't show up on my system, either of my systems. So I'm just going to open this. I'm going to open it this way so you can. Let me see if I can make this bigger for you. All right. I guess we're going to have to play ball this way. All right. Let me see if I can make it at least a little lighted for you. All right, so I'll zoom in if that's not visible enough. Let me see here. All right, so let me look at my grading stuff. It takes me 3 different papers to do one. So, all right, just bear with me. The world has changed, and I'm trying to keep up with it. All right, that glares too much for me. Okay, let's see here. Okay, number 1, perfect. 2A, perfect. Okay, A, B, and C. All right, let's start there. A, B. Okay, -3, that's wrong. This is a greatest integer function, and you can't plug directly into them because you're either going to be in the top step or the bottom step. You have to figure out which step you're on, and in this case, you're less than 2, so something like 1.9, which is -3.1, which rounds down to 4. Remember, this is a rounding down function, and at every integer, that's where it jumps the step, and you're on the lower step, and you gave me the upper step, right? You rounded up, and this needed to be rounded down. So I had mentioned in the lecture this was a special case. I also mentioned this was a special case. So B and C I mentioned were special cases. So let me see. So that one we just did should have been -4. Okay, now this one, this is creating a gap. This function, what did you write for this? No, it's the same thing over the same thing. If you have the same thing over the same thing, it's a ratio of 1. So the top's always positive. The bottom can be positive or negative. So the ratio is positive or -1. So if you want me to draw that for you, x is -4. All right, if you want me to draw that for you, just because you may want to see that, -4 is 4 to the right. All right, so it's either going to be +1 or -1. That function looks like that. To the right of 4, it's +1. To the left of 4, it's -1. And in the middle, it's undefined. So I asked you to come in from both sides. So it's DNE because there's a gap. What did you write again? You have infinities. No, the answer to that one is DNE. You want to write DNE for that. Coming in from the right, it's +1. Coming in from the left, it's -1. So overall, it's DNE. Okay, these were good. These were good. F. Okay, what did you do on F? Let me see here. You approximated it. Okay, for F, what I wanted you to do is use the special trig limits that I taught you guys. Let me show you. 1 second. So there's more than one way to do this. I multiplied by x over x. I put one of the x's on the bottom of this, one of the x's on the top of this. This one you can flip, this one you can't flip. So this one is a 0, this one is a 1, so overall it's 0. Some people multiply by 1 over x to both sides. Let me just write that out if that's easier for you. Okay, what some people do is it's a little easier for them to multiply by x on the bottom of each of these. They just see that better. So it's like multiplying each side by 1 over x. That's the same concept, which gives you this over this. So the limit of 0, the limit of this is 0, the limit of this is 1, and 0 over 1 is 0. So just however you see it. That was the special trig limits. All right. These all look fantastic. Very good. Same thing here, fantastic. Okay, number 5, let me see. Okay, give me a second to dig that up. I don't know what page that's going to be on. Number 5, no. Just give me a second to dig that guy up. Okay, there we go. All right, let me see here. Everything here looks excellent so far. It looks perfect. Very nice. Let me see. It must be on the next page. It's a -2, so it's a small error. Oh, you know what, Catherine? You forgot to take the limit. This is not the derivative right here. It's the limit as h goes to 0, right? That's the formula. You have to do the limit of the difference quotient. So because you didn't let h go to 0, this h should be 0. The derivative is 5. The slope is 5. So all this stuff, let me show you in my notes. That's part of the formula. Right, let me show you this. This is part of the formula, letting h go to 0. So you went to here. Sorry, you went to here, but you didn't do the last step, which was to let h go to 0. So this is actually the derivative, not that. This is. And then you plug in 1 and to get the slope. And then I could see from your work that you knew to plug in to get the slope. So even though that's wrong, I actually gave you that. And same thing, I could see that you knew how to find B. So I gave that to you, even though this answer just looks bizarre. But that is where the 2 points are coming off, because you never took the limit. And because you never took the limit, it screwed up the rest of it. So just know when you like redo this for yourself that you should be getting to here. You let the h go to 0, you plug in the 1 to get 5, and then you find the B. So that was just the only little error. You understood everything else, which was really nice. Okay, continuity you look really strong on. Let me just see, you got just little mistakes here. Part B, let me just eyeball what you have here. What did you write? Oh, that's not removable, that's a gap. This is non-removable. I just had rough sketched a similar concept for another student. So you have one line going up to 7, another line going up to 6. It's a gap. It's a gap at 2. It's a gap at 2. So we call gaps non-removable. This is non-removable at 2. So you were really close. You just didn't know quite what you were looking at. So you got that it was at 2. You didn't get that it was non-removable. You got that it was removable, which means to me that you thought it was a hole. It's not a hole, it's a gap. The only thing that classifies as removable is a hole. All right, so that was the 2 points off. C and D were perfect. E, let me eyeball that. This was so close. This was so close, it was painful. You have to remember that this was not the original function. Oh, you did that so good, and this one is a bit of a toughie. You did it as if it was cosine x. It's cosine 2x, right? So like this is the answer you have. X is that, right? Which is so close, except we're doing a 2x, not an x. So you just needed to divide off the 2. And this is the answer here, this part. But that is such... that is so good. That is so good. Some students can't come up to that part. So that's great. You've got that. And you said it was non-removable, which is correct. VAs are non-removable. They're not fixable. Okay, Catherine, I hope that helped. Your test looked really good. The thing with the limits is that, as you can see, you can't really give partial credit on a lot of them. So it knocked you off. So I'm expecting, just overall looking at your work, you're going to score higher on the other tests where there's more steps. Like you sort of have these right or wrong. There's no like middle ground. And on problems where you're showing work, I can see you know the process, and so I can just give you most of the credit. All right, that's it on this one. I will catch you. Hope that helped.